So please, I'm going to ask right now. Yes, Sona, thank you very much for recording. We're going to start right now. Again, huge welcome on behalf of ATRIUM and LUMEN to this webinar, Making Meaningful Data Work Together. So our topic today is semantic artifacts. That's our main topic today. This session is, it's organized by two projects. Both are EU-funded projects. So ATRIUM aims to explore and strengthen complementarities between four research infrastructures. So we're talking about DARIA, Ariadne, Clarion, and Operas. And our goal, please keep your mics off, please. And the goal of this project is to improve access to services for researchers across countries, languages, domain, and media. LUMEN. The goal of LUMEN is to advance cross-domain collaboration in discovery processes in four academic fields. So we're talking about maths, social science and humanities, earth system sciences, and molecular dynamics. These two projects, they will end next year, so we still have 1.5 years, more or less, to go. And we have a common topic, semantic artifacts. So we're talking about ontologies, controlled vocabularies, metadata schemas, and they are foundations to interoperability. But we have challenges in the creation and management of those semantic artifacts. So today, we're going to touch on diverse topics, FAIR principles, data integration, paths toward more scalable semantic artifacts workflows in the arts, social science, and humanities. For this, we bring to you three amazing speakers. I'm going to introduce them to you right now, so then when we start the presentations, we can go in the flow and don't interrupt the presentations. So let's start introducing them. First one is Julien Homo. He's a data architect, founder of FoxCub, which is a strategic consulting and data and AI architecture company. With over 14 years of experience, he advises and delivers large-scale data architectures for national research infrastructures and European ecosystems, as well as for major corporate groups. He leads technical foundations for strategic Horizon Europe programs, and this includes LUMEN, ATRIUM, Graphia, and Triple. His expertise spans semantic modeling, knowledge engineering, AI-driven enrichment, and interoperability strategies. Julien Homo, thank you very much for coming and welcome. Our second guest is Massimiliano Carloni. He is research data engineer at the Austrian Center for Digital Humanities. He's currently leading Work Package 3 in ATRIUM, focused exactly on semantic artifacts and how to enhance their discoverability and interoperability. His interests include data modeling, digital preservation, and the application of digital methods to the study of antiquity. He's also the main responsible for the vocabs service of DARIA and one of the ATRIUM services. You can check the catalog in the website. Massimiliano, also thank you very much for coming and welcome. Our third speaker is Florian Lemoine. He's lead engineer at eScience Data Factory with experiences in software development, in startup, scale-up, and corporate organization. He's currently exploring how semantic artifact management can be industrialized, one important topic of today, bridging structured project methodologies with scalable knowledge workflows. His primary interests include no-code, low-code platforms, and AI agents for automation of manual processes in development and the application of agile methods to complex technology programs. Thank you for coming here. And right now, let's go to the presentations. I pass the floor to Julien to start our presentations here today. Yeah.
Could you see my screen?
Yes, now I can hear you as well right now.
You can hear me.
Yes.
Thanks a lot, Carol, and hello, everyone. I'm really glad to be opening this session with you today. So let me start with where we are. Our communities have actually come a long way over the past decade. We have built more shared infrastructure, more digital archives, more semantic standards, and more linked data initiatives.
Just a second, Julien. Sorry, because we're seeing your screen is black right now.
Okay.
Yeah, let's try again.
Try to do it again. Yes, thank you.
Yes. Let
Is
me
it okay
see
now?
right now. Yes. When data
Okay,
can travel, that's where we are.
okay, okay.
Okay, so
So
let's start
I was
again.
saying, okay, thank you, thanks a lot, Carol. So we have built more shared infrastructure, more digital archives, more semantic standard, or more linked data initiatives than ever before, and the level of awareness across SSH today is genuinely remarkable. We work in a moment of extraordinary data abundance in our community, and yet the data we have doesn't travel well across our research environment. There are three layers of friction still conspiring against us, and I would like to take a minute to name them in this introduction. The first one is what I will call vocabulary friction. The same person can be called author in one database, creator in another, author in French records, Verfasser in German's one. So we end up with the same entity sitting behind four different foreign keys and no shared identifier to bring them back together. The second friction is structural. Imagine you want to bring together in a single workflow a TEA corpus, which is how our community encodes digital text, a Siloxerem catalog, which is the ontology cultural heritage institution used for their collections, and a DDI dataset, which is how social scientists describe their surveys. The day you actually try to do this, you find yourself reconciling three different times model, four different ways of describing actors, or two competing place taxonomies, all colliding at once. And the third one is sheer scale. We have hundreds of vocabularies in our communities, dozens of overlapping ontologies, no governance, no single map across them. Now, the cost of all this is very concrete, and I would like to make it concrete with one query. Imagine you want to find every 18th century European female playwright mentioned in archive correspondence, for example, and link her to her published works. That single question already crosses four cataloging standards, that is TI, EAD, MARC, and Dublin Core. It also crosses three authority files, VIAF, ISNI, and GMD. And beautifully for the 18th century, it crosses two different calendar systems, the Julian and the Gregorian one. Same year on paper, different actual dates depending on the country. So today, this single query takes weeks of manual reconciliation per researcher. Which is why, if you take one thing away from this opening, I would like to be this. The bottleneck in our community is not longer storage, it's not longer access. The bottleneck is meaning. So if meaning is the bottleneck, then we need infrastructure for meaning, and that's exactly what semantic artifacts are. We will talk about this concept a lot today through this webinar and during the next section. But the official definition, the one you will find in Ferrosphere and in the EOSC interoperability framework, calls them matching actionable formalization of a conceptualization, which is the careful way of saying that there are shared computable computable agreements on what things mean. And what is interesting is that they come in a gradient. At the simple ends, you have control vocabulary, which are basically a grid list of terms. Going up from there, you have taxonomies, which add hierarchy on top. Then theory, which also add synonyms and relationship between them. Then metadata schema, which structure how you describe things. And at the most expressive end on the right of the spectrum, you have ontologies, which are fully logical models that machine can actually reason over. And the right tool depends on what you are trying to do. But across the whole variant, all of them share the same core purpose, which is making meaning travel between systems. But we will dive into the details in a few minutes with Massimiliano and Florian. Now, here the point. This kind of infrastructure is not a future promise for us. It's already there. And most of you in this workshop, in this webinar, are using it every single day, often without even thinking of it as such. If you work in cultural heritage, you have encountered Siloxerum, the ontology museum used to model their collection, plus the Getty vocabularies for art historical naming, and the Europeana data model that aggregates digital heritage across Europe. Also, if you work with text, then TEI is your daily companion, the way your community marks up scholarly editions so machines can read the structure. This is another usage. If you work in the social sciences, then DDI is foundational. It's how our community documents, surveys, and observational data sets, often paired with other thesaurus like ELSST or CESDA, that translates social science terms across European languages. And underneath all of this, there are cross-cutting standards that quietly hold the whole landscape together. SCORS, for publishing any thesaurus as selling data, Dublin Core, the minimal metadata schema you will find behind almost every digital object, and, for example, also Provo, for tracking where data comes from and who has touched it. So if I had to summarize where we stand, I will say that the SSH semantic landscape is not empty, not at all. It's actually quite crowded, which means our real challenge today is not to build more of these things. Our real challenge is to make what we already have actually connect. And to conclude this introduction, all of this naturally brings us to FAIR. We all want our data to be findable, accessible, interoperable, and reusable. And what is important to say clearly is that semantic artifacts are what actually makes the I and the R technically possible. The I for the interoperable, R for reusable. Without shared meaning, there is simply no interoperability. But there is a recursive twist that the Fair Impact project has put at the center of the conversation, and it's the following. The artifacts themselves must be fair, because if the ontology your data depends on disappears, or becomes undocumented, or stops being maintained, then your data effectively goes dark with it. So in this space, 3 open challenges remains, and these 3 challenges are basically what the rest of this webinar is about. The first one is governance. When a project fundings end, the vocabulary that came out of it very often dies along with it. This is a cross-cutting concern that has no single owner today, and it's something the broader community needs to take on together. The second one is mapping. When you have 2 ontologies covering the same domain, they almost never agree on the same terms, and connecting them is genuinely hard work. And this is, by the way, is exactly what Massimiliano is going to take you through next with ATRIUM. And the third one is about industrialization. Every new artifact today still takes months of artisanal craft with no shared tools chain to support this life cycle. And this, in turn, is exactly what Florian will take you through after Massimiliano with the LUMIS platform through the LUMEN project. So with that, I will stop there. I will let you, Massimiliano, the floor. And thanks again.
Thank you, Julien. Massimiliano, the floor is yours.
Thank you, Julien. Okay, so let's take a step back. So we are going to ask ourselves a question. What is a semantic artifact? And we're going to try to reply to this question by using an example. imagine you have an empty room and you want to furnish this room and you want to describe what is there, because maybe you have to pass this information to another person, maybe you have to write this down for having a checklist if everything you need is there. So we add a chair, and then maybe we add a second chair. And apart from the fact that these might be two different models of chair, what we're interested in is to describe that we are using two objects that can be defined as chair through a common category. We can think of this category as a class. So a category that encompasses all these objects in its commonalities. We can add a table, for example. And we can even say that the whole room is a class. So it's an instance, one example of the class of the category room. And so now we have already three classes: chair, table, and room. We can also add another seating, which you might say this is an armchair. So this is yet another class, but we can still say that armchair is kind of partly a chair. So it's just a more specific way of saying chair. And we can say that this is a subclass of chair. So we can basically link armchair to chair through this subclass relationship. We can add a lamp. And if we want to be very precise, then we can also say that, a lamp has a light bulb, maybe. But we also want to express this relationship between the lamp and the light bulb. So we can really add something like this has, which is a directed property from lamp to light bulb. So it has an arrow that goes from lamp to light bulb. And we can call this a property that connects two objects together. And properties can not only connect two objects together, they can also connect an object, for example, to a value, a measurement. So for example, in the case of the room, we can say that the room has a certain height, and it also has a certain width, so 3 meters by 5 meters. And we can say that these are two properties of the room, so 3 meters and 5 meters, height and width. All this, and of course, we're going to add a poster with ATRIUM and LUMEN because we like the projects. But all this, it's as if we built a very small ontology. So an ontology is a formalization of a specific field, and it describes first what kinds of objects exist in our world, and these are the classes. So these are the categories that we created before: the chair, the table, the room. The ontology allows you to express which are the relationship between these objects, and these are the properties, or the relationships between an object and a value, a measurement, in the case of the room. And we can also say, we can also express rules that these objects should follow. So for example, we can say that a chair must have at least one leg to infinite legs, for example, and we can call these restrictions. Why do we need these ontologies? And more generally, an ontology is a kind of semantic artifact. So why do we need semantic artifacts? As Julien already explained, we need this to make machine-readable statements. If we are humans, of course, we can say Vienna is the capital of Austria, and we understand each other. But if you're a computer, then you have to say something a bit more, because a computer, for example, doesn't know from previous knowledge that Vienna is an instance of the class city. We know that Vienna is a city, but we have to define this formally for a computer, and we can do this with semantic artifacts. And we can say that this Vienna has a property is capital of, and we can even say that this property usually connects a city to a country. And we connect this property in this case with the Austria, so the instance of class country. So we now have a sequence of subject, predicate, object. Vienna is capital of Austria that can be even read by a computer. And to complete this, actually, we can also assign to each of these elements what is called an identifier in our system. So this is actually real identifiers that come from a specific system, the one from Wikidata. But Vienna is defined by Q 1741, the property P 1376, and Austria Q40. Why do we need these identifiers? Because if I'm talking about Vienna, I want to be clear that I'm talking about Vienna, Austria, for example, and not Vienna in the state of Virginia in the US. And Vienna in Virginia will have a different identifier for the computer. So there is no way that the two objects are confused with each other. Julien already gave an overview of what kinds of semantic artifacts we have. So we can have control vocabularies, thesauri, metadata schemas, and ontologies. I would like to make an example of how these can be used even in an integrated ecosystem. So imagine you have a control vocabulary for theme genres, and you have drama, comedy, sci-fi, and dystopia. If you have a thesaurus, you can say a bit more about, for example, dystopia. You can say that dystopia is actually a subgenre of sci-fi. So you can put a hierarchy in these theme genres. You might have also a metadata schema where you say, we have a field has genre for each movie. And you can even specify that, this has genre must be filled out with one of the values that come either from the control vocabulary or the thesaurus. And finally, if you develop an ontology, you can create fully fledged inferences. So for example, you can say that if work has genre dystopia, then automatically you can infer the statement that the same work also has genre sci-fi. You can create these inferences without explicitly saying them beforehand. These are some of the examples that also Julien already mentioned. So this is a quite popular thesaurus that's used in a lot of systems and allows you to describe art, architecture, and cultural objects. The hierarchy is quite deep, so you can see that if you click on one of these little icons with the three squares, then you can open up deeper hierarchies, and you can see how deep this whole hierarchy can go. So it's a very complex thesaurus that has tens of thousands of concepts. You also have, for example, as metadata schema, Dublin Core. And as Julien mentioned, the strength of Dublin Core is that it's generic and minimal enough that you can use any of the fields that you find defined here. So any of the properties like creator and date, you can use them for a whole range of resources. So basically, any digital object might have like a date or a description or a creator. And there's also like a more expressive evolution of Dublin Core, which is the DC terms that allows for more properties. And this is extremely important because having like this minimal metadata allows different systems to speak to each other, because if they all express their properties through this schema, then they have a common ground. And the same goes for something which is a bit more complex than Dublin Core. This is the CITUX-CRM model, and it's used for cultural heritage, museums. And this is a complete ontology, but it's an ontology meant as a meta model, as a meta ontology. So it's actually being developed as a language that different systems can speak to interact with each other. And it's mostly based on the idea of events. So the creation of the object, the beginning of existence of an object, actually, or the end of existence of an object. One thing that you might notice, because you can see many different ontologies, control vocabularies, and you might have some doubts, some remarks. So, for example, I put dystopia under sci-fi. Maybe some of you might have a question and say, no, that's not really correct. The important thing to notice is that semantic artifacts are usually interpretative choices. So they reflect the understanding of the word by a specific team person. And they are made specifically for a purpose, for a system, for certain requirements. So I can develop a semantic artifact where for example, I read like how many chairs there are in my room, but for example, I'm not interested in how much moisture there is in my room, because my aim as an interior designer, for example, might be different than the one who is trying to sanitize this room, for example. And so each semantic artifact creates, let's say, a word per se that fulfills some specific requirements and purposes. And also sometimes it's difficult to distinguish between different kinds of artifacts. So, for example, the boundary between a control vocabulary and a thesaurus sometimes is very difficult to establish. And even between a thesaurus and ontology, sometimes it's a little bit blurry. Also, if you followed the presentation until now, you saw that there are a lot of semantic artifacts out there. So we just mentioned the most popular ones, and still there were like tens of semantic artifacts. And sometimes we might even, I say this provocatively, but we might even have the feeling that there are too many semantic artifacts, because each project creates its own semantic artifact, its own ontology. And sometimes they don't really speak to each other. And so we have, in the end, this question. We can ask ourselves the question. We have this doubt that maybe these semantic artifacts don't really fulfill their promise to make data linked, machine readable, and interoperable. And this is one of the questions that we try to address with ATRIUM. So one of the things we did, we wrote this 80-page document where we try to analyze what models and formats are used in the field of the arts and humanities. And we listed over 130 semantic artifacts with details about these artifacts. And we also examined in much more detail a selection of 40 semantic artifacts that were particularly relevant for the community or for the project. And this was a collaborative effort between the 4 EU infrastructures involved in ATRIUM, and it's available freely on Zenodo. You can see here an example of this list of semantic artifacts with details about the formalization of the model and the documentation. And you can see also here an example of the more detailed treatment of a specific model, in this case, Sidox-Siren. And the other question we addressed in ATRIUM, so on the one side, it was collecting semantic artifacts and seeing what's out there. But the main question is, how do we address the semantic gap? And to explain this, imagine that the ATRIUM project, for example, has created a class room, and the LUMEN project has also created the class room. How do we connect each other? So how can we be sure that what we say as room is the same as what LUMEN says as room? The label, it's not enough, because room, we might intend room as the structure of a building, but maybe LUMEN is using room in a different sense. Maybe they're using room in the sense of space. Is there enough room here? And we cannot be sure just from the labels if the two categories match. But let's say we know that we match. How can we express this in a computer readable way? And we do this by using mappings. So for example, we take the two categories. These things before the column, they are used to say that this room on the left belongs to namespace ATRIUM. So it was, let's say, created in the realm of ATRIUM, and the other one belongs to LUMEN. And this is short ways to express this. But we take these two concepts with these two classes, and we say that they are equivalent classes in the OWL language. And just to explain very quickly, the OWL stands for Web Ontology Language. So it's a language to express ontologies and relationships between ontologies. And there are different kinds of properties you can use to express these mappings. So we're not going to go into the details of each of them, but you have Scott's exact match, for example, you have all same as, and these are used throughout the web to express these mappings. But sometimes we don't have these mappings, so they're not really explicitly stated between classes. And even though we don't have these mappings, sometimes the answer is there, so the mapping is somehow there, but it's just hidden. Let's take the example of these two concepts that we have. So one is from the Central Library of Florence, is Barocco, and the other one is Baroque, a topic in the Vienna History Wiki. They are explicitly unrelated to each other. So there is no direct connection between this concept in the Central Library of Florence and the Vienna History Wiki. But the Central Library of Florence in the record says that Barocco is connected to Baroque in Wikidata. And the same goes for the Vienna History Wiki. It is explicitly stated that Baroque here has an exact match Baroque in Wikidata. So from this common reference to Wikidata, we can infer that Barocco in the Library of Florence and Baroque in the Vienna History Wiki are interconnected. So they're actually the same concept. They express something very, very similar, and we can map between each other. And we do this also by leveraging the possibilities offered by connections of nodes, which we usually then call graphs or knowledge graphs. And we'll mention knowledge graphs in a second again. So when we dealt with this general challenge in ATRIUM, we also asked ourselves three main questions. So how do we compare, for example, data catalogs with each other, data catalogs from the European data landscape? How can we find existing mappings within semantic artifacts, even though they're a little bit hidden? And how can we suggest new mappings? And to develop our reply to this, we formalized a series of criteria strategies. And one was we would like to embrace the complexity. So sometimes it's not really possible to create exact mappings. And that's fine because, you know, the data landscape is diversified. Every system uses its classification scheme. And we have to allow for also a little bit of, you know, freedom and, you know, richness in expression. But the second main criterion, we want to use what we already have to its fullest. So we don't want to invent too much new, because that brings even more complexity sometimes. We want to use what we already have. And we want to allow, and the third point, we want to allow the user for selecting how they want to view the data, the mappings and the relationships between the data catalogs. So we want to give the options in the hands of the users. And finally, we want to design with modularity, expandability, and scalability in mind. Our reply was MetaCat. So this is a work in progress tool. It's a twofold platform. So on one side, it's a platform to collect statistics about data catalogs, visualize and compare them. On the other side, it's a platform where you can collect semantic artifacts from catalogs and find potential mappings. So for example, if you want to ask the question, we want to reply to this question, how many 3D models are in all these 4 data catalogs? So these 4 data catalogs are actually the catalogs of the 4 infrastructures involved in ATRIUM. We ask ourselves how many resources of category 3D model are in each separate catalog. And we ask ourselves at the same time what mappings are available or can be found by this inference method between categories 3D model across these catalogs. And we load everything in a unified data space, and exactly a knowledge graph with nodes and edges. And this allows us to find these connections almost automatically and to respond to the question across these catalogs, how many 3D models are over there? This brought us some interesting results and perspectives. So we actually saw how many different classification schemes there are across data catalogs and how is the coverage. So some data catalogs, they have a lot of 3D models, but others are specialized on other kinds of resources. We found a wide variety of what we call submerged mappings. So these hidden mappings that we can, maybe sometimes they're also in databases of the catalogs that are not used that much, or they can be inferred through common relationships. And also we would like to expand MetaCat to further extend the scope of application. So we would like to include more catalogs and methods. So for example, artificial intelligence supported ways to create mappings between 2 semantically similar concepts. So thank you. And now I will leave the floor to Florian.
Thank you, Massimiliano. Florian, now the floor is yours.
Yes, thank you, Massimiliano. So let me share my screen. All right, so we've seen what a semantic artifact is and what it takes to enable interoperability via mappings. And thanks again, Massimiliano, for the explanation. So now the question is, how do we actually build a semantic artifact and how we are keeping it alive? Yes, so building semantic artifacts today means navigating a fragmented toolkit. So this is a garage, where you have all those tools. So anyone building a semantic artifact has to juggle a wide range of tools like Protégé, Web Protégé, TopBread, Workbench, and many others. So some are open source, some are commercial, others abandoned or maintained by a single PhD student who graduated in 2014. So they rarely interpret binary. Yet, the field has produced strong methodologies. So LOT, for instance, linked open terms, offers an industrial iterative process for developing semantic artifact designed with linked data and fair publication in mind. SAMOD, another methodology, brings iterative test-driven cycles built around competency questions. On top of that, the community has converged on best practices. The Homo Foundry sets the gold standards with principles like orthogonality, reuse, and open licensing. The FAIR principles that Julien mentioned, findable, accessible, interoperable, reusable, which is strong principles, ensure that we build today remains usable tomorrow. By the way, the company I'm working for has been part of the definition of those recommendations. So the tools may be scattered, but the methodology and principles are solid. They are here. The real challenge is making them work together as a single repeatable process. In one word, industrialization. That's the gap LUMIS wants to fill. So in one sentence, big one. So LUMIS is a deliverable part of a LUMEN project, and LUMIS is a collaborative environment orchestrating open source software to build, manage, publish, and maintain fair by design semantic artifacts using industrial standards, methodology, and best practices. Big pause. So before looking at our first use case, one important note, LUMIS is a project in active development. So what I'm about to walk you through is a mix of current product, our vision, and our roadmap. So the use case. So is our first use case captured as a simple user journey. So as an ontologist, I want to create my semantic artifact and publish it on OntoPortal using the LOT methodology we discussed about. So on the right side, you have Parmenides. Okay, it's our ontologist. Parmenides is the person actually doing the work. And yes, it's his real name. So in the middle sits the semantic artifact. Is building the concepts, the relationships, the rules that capture the domain. And on the other end, you have OntoPortal. So a quick word about OntoPortal, in case you are not familiar. So OntoPortal is an open source platform for publishing and browsing semantic artifacts. It's the technology behind portals like BioPortal, AgroPortal, EarthPortal, and many others. So together they form the OntoPortal Alliance. So that's why we want our semantic artifact in that Portal Alliance. So LUMIS will support this whole journey end-to-end guided by the LOT methodology. So LOT organize the work into 4 iterative activities. It starts with requirements, gathering use cases and defining the competency questions the semantic must answer. Then come the implementation, so modeling the conceptualization. Looks easy. And next is the publication, so releasing the artifact online with stable URIs, proper documentation, and content negotiation. And finally, maintenance, so versioning, bug fixes, and evolution over time. So each activity that is here in the slide supports the others. And as you can see, this cycle repeats. And that's the maintenance as well. So as needs evolve, as feedback comes in, as the domain changes, we loop back through requirements, implementation, publication, and maintenance. Next, I'll walk through how each activity plays out in practice. So let's start with competency questions. On one end, it's a question a human asks in plain language. Anyone can read it. It comes straight from the people who will actually use the artifact. Which datasets describe air quality in European cities since 2020? On the other side, it's a matching execution test, a Sparkle query. I won't read it. That runs again the artifact and the sample dataset, checking whether the model can actually deliver the expected answer, just like a unit test in software engineering. So a common approach is to manage competency question in a spreadsheet. It works, but it comes with real risks. Competency question can get out of sync with the artifact, lost between versions or forgotten onto the modeling stack. So with LUMIS, we want competency question to be at the heart of the platform. It's the core, how to say, a piece of the load methodology. So this is what we want. So they capture the competency questions through a structure interface, ideally linked directly to the classes and property of the artifact, ideally, pair with their Sparkle tests, version alongside the model, and re-execute at every iteration. So next one, once we have our competency questions, we can start modeling the semantic artifact. And for that, we use Protégé, the most widely used ontology editor in the world. Protégé is open source, maintained by Stanford, and the de facto standard for building ontologies. But Protégé alone has one big limitation. When you model in Protégé, you produce a file sitting on your laptop. And the moment that file is shared by email, by Slack, or by a USB stick someone found on a drawer from somewhere, you've lost control. That's exactly why we are building the LUMIS plugin for Protégé. The ontologist still works in Protégé, same interface, same shortcuts, same reasoner, but now Protégé is connected to a platform, LUMIS, and that connection brings three things that change everything. So the first one is a centralized storage. The artifact lives in LUMIS, accessible to the whole team with one source of truth. Second, automatic versioning. Every save creates a tracked version. You can see who changed what, when, and why. And third, rollback. You made a mistake? It's okay. One click takes you back to any previous version. Easy. So quality. Three excellent tools already exist for assessing semantic artifact quality. So Shackle validates data against shapes, rules like cardinality and data types. FOOPS links the ontology for modeling pitfalls, and FOOPS scores it against the FREIR principle. So basically, it gives you a score. But quality isn't a one-time gate. It has to be continuous. If we are in the industrialization path, this is exactly what we need to do. So, and those tools right now live on 3 different websites with 3 different interfaces and 3 different reports. So running them manually on every version doesn't scale. That's where LUMIS comes in. We're integrating them so they can be run automatically on every new version. And the result is a unified report covering conformance, pitfalls, and fairness, wrapped in one place over the time. Once the artifact is modeled, version, validated, but it's time to publish. What you see on the right is the Ontoportal Alliance. As mentioned, it's a federation of domain-specific ontology portals. If each portal requires you to follow a common submission process, publishing your semantic artifact manually may be a burden for a long run. So that's why you are building connectors. You configure the connectors once, you point it at the portal you care about, and from then on, every release of your artifacts can be published to every portal in your configuration. Easy. I mean, it looks like easy. And the final step is maintenance. And maintenance is how good you are at repeating the same story over and over and over. With only a semantic artifact, there's nothing to maintain it with. No test, no story, no way to know if a change broke something. Why a concept was introduced in the first place, for example. So that's why Loomis extends what a semantic artifact actually is. Around the model, at the center, we deliver everything maintenance requires. So tests, history, quality monitoring, provenance, mappings. So the maintenance moves from a heroic effort to an industrial system. And that's it for me. So Loomis is a work in progress, and that's the best time to get involved. So please follow the LUMEN project and don't hesitate to reach out to Julien, to me, or to the consortium. Thank you very much.
Thank you, Florian. As you can see, it's a lot of work going on under ATRIUM, under LUMEN, and our goal is to try to help the end users, the researchers, you, with solutions that make your life easier in research. So right now, I would like to open the floor to you. If you have questions, if you would like to address any other doubts, I'm inviting my colleague, Fotis Mistakopoulos, from Operas, to help us here in the discussion. Florian, can you stop sharing, please? Yes.
Florian is sharing, so if you can stop. Yes, thank you.
Yes.
So what I will do, there is no questions in the chat per se, so I'm curious if there is anything that that people would like to actually raise here as an issue before we go to the Mentimeter. We have a very short kind of Mentimeter where we would like to ask you a few questions based on the discussion that we just had, and you can see here, you can either scan the QR code or even I think in the slides, Carol, we have the links. Do you mind sharing them in the chat? But you can see here, everyone can see here, like if you go to menti.com and you add this kind of code, 15768146, then you will join the Mentimeter. Thank you very much, Carol. So yes, so we try to think of a few questions that relate, of course, to the topics discussed here. And our speakers are always available to address any of the comments that are mentioned here. There is actually something that Leva, if I'm not mistaken, or Eva wrote in the chat. For someone who is still learning, please explain the similarity or difference between a semantic artifact and a digital twin. Thank you in advance. So this is a great question. Who can, out of the three speakers, give us a little bit of clarity, the difference between a semantic artifact and a digital twin? Who would like to take this on? Anyone? Florian, Massimiliano, Julien, in that order? What kind of feedback you may have?
What do you mean by digital twin? I'm a bit confused. Sorry.
Okay. So yeah. Sorry, Carol. What did you say?
From the cultural heritage, more context. I think Massimiliano can help us here, especially from the ATRIUM. We have been working a lot with the cultural heritage contest. So I think you can help us here, Massimiliano.
Yeah. Okay. So I don't have that much experience with digital twins because they are they're being developed in other projects right now, but ATRIUM, they also play a role, but like it's central, for example, to the Artemis project. So from what I know, actually, a digital twin can integrate semantic artifacts. So they can, for example, use ontologies to describe properties of a certain object. And they can also, for example, integrate like little knowledge graphs, for example, explaining the history of the object, the background of the object. I think actually that digital twin, although it integrates semantic artifacts, is a bit of broader kind of object. So it has also things that are not just semantic artifacts. So it can use semantic artifacts, or it can integrate graphs, but it's kind of a bit of a broader concept because it can also include like measurements from sensors. So the organization can be that of a semantic artifact in part, but it can be something a bit broader. But as I said, I'm not working on digital twins exactly, so my response has to be a bit vague.
Thank you, Massimiliano. I also would like to invite if there's someone here from Artemis project or the cultural heritage field, if you'd like to add some thoughts here, it's pretty welcome.
Of course. Until someone actually wants to add something, I don't see any raised hands as well. So I'll just want to ask again the speakers, which challenges resonated most with your experience? And we can see that fragmented vocabularies and tautologies is the most popular one in this case, but very closely followed by the rest of the answers. Is that also your perception, or do you consider all of these options, let's say, equally challenging? Let's say, does this answer kind of surprise you, the distribution of answers here?
If I may, for this, for me,
Yep.
I'm not surprised. I don't know if we should have other challenge because the other answer is with 0. But for me, the distribution for me is my perception through the different projects we have seen and the real challenges we are facing. So no, I'm not surprised, and we are trying to address these challenges through the 2 projects. So yeah, no, I'm fully aligned with this.
I understand.
results.
I understand. From my on the outside looking in, for me, it's also the most the thing that is like easier understand, like fragmented vocabularies and tautologies. It's the one thing that it's always discussed in many contexts beyond, Lumen. Also, I think it's very much a reality. But I can also see, like, from the presentations, like how the rest of the answers can also become relevant as we move along. So I'm going to move to the next slide, but there is also a question in the chat again. In your industrialization strategy, do you have a plan for knowledge graphs?
As far as I understand the question, semantic artifact, ontology is knowledge graph. So that's why I don't know how to answer that question. If you can add more precision or description or of what you want to understand better.
Well, first, instantiated ontologies.
Yes, the idea on the ontology publish is, of course, annotate the data with and to test, test what has been built with the competitive question, described at the beginning of the industrial process. So definitely, this is part of our strategy. I hope I answered the question.
Thank you, Florian. It's nice to see that a combination of both is being the main answer. It's good to know.
Yes.
Especially as a person involved in 2 projects. So I feel really happy to see this. Because of course, when we have these EU-funded projects, we want to address real-life challenges. So it's good to know that you see relevance in the approach.
So yes, the dominant answer seems to be a combination of both. So thank you very much. Again, in the interest of time, I have to move to the next slide, but thank you very much. How ready is your organization to adopt an industrialized approach to semantic artifact creation? So this question, in my view, can be a little bit tricky because you have to know the wider context, I think, of your organization in the context of the discussion that we had. But I'm really curious to see what people think and feel about this. Again, very interesting split, but I think we are averaging on a more positive response based on what I can see here. But of course, grounded in the middle in many ways, which is now, I think it's going towards the negative aspect. So interesting. So I don't know how to, somewhat ready, whether it includes also some sort of part of the negative aspect as well as the positive, of course. So very interesting way of looking at this graph, I think. Any kind of comments from our speakers looking at this split here? Does this surprise you, or do you think it's yeah? Did you expect that?
If I may, I mean, I'm not. I wasn't expecting anything from that question, to be honest. What I would like to say is that industrialized process you already, have in place and which is working. If there's no point,
Yeah.
So the difficulty here is change management. If you are taking, I don't know, 1 week to create and maintain an ontology, and we offer you, tools to reduce by half this time, maybe you don't care, in fact, because you are doing it in 1 week and you are mastering your whole chain. The difficulty is when you will leave, when you will do something else, and someone will take over your job, what will happen? That will be really hard. So that's why industrialization is really necessary. Maybe not for all structure, all company, but somehow we need to think about it. I think it's important, at least, to think about it.
This is perfect. Thank you very much, Florian. There are 2 questions in the chat. And I'm moving to the next slide while we were talking about them. Could the LUMIS plugin potentially be integrated into other software in the future, such as Workbench?
So I think it's a question for me. We're thinking about it. I'm not sure if we will make it. From my understanding, it's really complex to have something integrated within Workbench. But we'll think about, how to at least integrate other modeling tools within LUMIS, which is through a plugin or a connector, web connector, or whatever. So, this is a question we have, and I think we will manage it. Yeah. Thank you.
Thank you very much. Massimiliano, Jan Lefranc is asking you a question directly. Are you planning to align with the ongoing effort to standardize and verify mapping started with fair impact and currently continued within the RDA fair mapping working group?
Yes, the answer is yes. So we are exploring potential connections with other projects and initiatives. And we also had a meeting a couple of months ago with different representatives from different, for example, initiatives in control vocabularies. And we are trying to align as much as possible with them, also using the scientific knowledge graph interoperability framework. So that's also something that we're trying to build, like a common infrastructure to talk to each other. Yes.
Amazing.
Thank you.
And Sasha added a comment about fragmentation in the chat, and I see Florian and Carol already acknowledged it. It's about fragmentation of efforts of different levels for organization, and new tools such as LUMIS that aims to bridge most used tools is really needed and welcome, even if more plugins are created. And here, I think this question was from us, like thinking about the next couple of years, maybe where to focus, how to prioritize certain topics. And It's very nice to see mapping and alignment services topping this. And of course, training and capacity is always a discussion around open science practices more broadly, and even more maybe necessary in when it comes to software and more technical aspects. So I'm not surprised to see it second. And we will definitely take these bits of information and see how the speakers and the projects would like to reuse them and how to prioritize the kind of different topics. And I will move to the final question. In one sentence, what will you take away from today's session? This is just an open space to comment on anything that we could just take as feedback to share with the speakers and of course the wider projects, both ATRIUM and LUMEN. And as far as I'm concerned, while you write your responses here, thank you very much for the questions in the chat. Florian, Massimiliano, Julien for presenting today, and Carol for moderating, and everyone who gave us the time and were present here today. Thank you so much on behalf of both projects.
We have here, and we repeat that already ahead of time, but we have a final question here. Maybe you can still address it if people are thinking about the one sentence and the final words. As there are smaller memory institutions that only now start or plan to digitize their archives, what would you recommend? You already mentioned that data need to be fair, but any further recommendations for making the digitized collections connectable to the rest of the EU? So that's like our final question here for this webinar.
Maybe I can try to answer this one. That's a really important question. I have in mind 3 recommendations. First, don't aim for full fair on D1. Start by being consistent internally with a simple, well-known schema like Juvencore or the Europena data model. A second recommendation will be to reuse existing identifier wherever you can, via for people, geonames, Wikidata, I don't know. Every time you reuse one, you are already plugged into the rest of Europe. And third, maybe join an aggregator early, Europena, Opener. They have solved most of the connectivity problems already, and feeding into them is much easier than publishing alone. And on funding, the data space for cultural heritage and digital Europe have lines especially for this. So yeah, I don't know if I answer your question, but some recommendation I can share now.
Yeah, Julien, so let's read the final sentences so we can close the session.
Carol, instead of reading the sentences, Claire Boardman, who is still here, is asking a question, a very simple question. Like, it feels like there are several Europe projects based working in this space and producing similar outputs. How are they being coordinated? Could we say at the EOSC level to begin with, for example? Julien, Massimiliano, what do you think? EOSC is definitely a place to start, where a lot of meetings happen and trying to align the kind of different priorities, correct? Is there other kind of, there's the Research Data Alliance, of course, who I think they have a lot of working groups within them, interest groups. So there are different kind of associations, let's say, and different places where people meet and they discuss the priorities and how to move forward and how to connect actually the different projects. That's my very, umbrella overview of this kind of 2 organizations that feel very similar to the project. Do you have a different perspective, Julien, Massimiliano?
No, I guess we are aligned at EOSC level. Of course, we are trying to address all these aspects through the recommendation, the working group, through the different bridge we are building between the project and also with the node in EOSC. So yeah, we are trying to bridge, to connect this initiative together in order to be coherent, consistent, and also to share the initiative between all the ecosystem. So yeah, definitively we are linked to them. I don't know, Massimiliano, if you want to add something regarding especially ATRIUM.
Yeah, I think also another major component is the research infrastructures. So because they usually participate in different projects, so across projects and in different fields. And I think that infrastructures like Clarin, Daria, Ariadne, and Operas, they can actually offer like this collaboration also, because the people that are working there, they take part in different efforts, so they can then bring these efforts together, even on a more like individual or team level. And of course, they participate also in the bigger EOSC federation meetings, and they can bring their knowledge there.
Thank you very much. I mean, you said that, I'm repeating some sentence reading here: common work, integrating efforts, interoperability, improvement. So we have here like semantics are the game, integrated tools for creating and mapping semantic artifacts, and some thank you for the presentation. So I want to use this opportunity to thank you again, Massimiliano, Julien. Florian had to leave, but it was a very interesting presentation. I hope you can follow us in the social media, follow our website, so we can keep looking at the developments and outcomes of both projects. We will share with you the slides, we will share with you the recording. You see our social media there. You can stay in touch with us, and I hope we will see you very soon next time. Thank you, Fotis, for your help as well, and see you next time. Thank you.
Thank you, everyone.
Thank you.
Thank you. Bye-bye.
Thank you.